study now Bangalore University BCA 5th semester's core paper Distributed Computing. This one is Unit 1 Session 1 lesson. We have to study in this session definition of distributed computing, history of distributed computing, different forms of computing, strengths and weaknesses. In traditional computing, we started with, or the development of computer science started with single computer and without any network. Very soon, the computer scientists started connecting two computers, and the concept of network came up. Concept of network helped us to share resources. One printer can be shared with three or four or sometimes even hundreds of computers can share one printer or sometimes one storage device. Later, when internet emerged, two networks can be remotely connected together, and the internet itself is the network of networks. So the two networks of two companies or two networks of a company in company's office in two different locations can be connected together using internet. Now the problem arised in networking or wide area networks or metropolitan area networks, etc. If a change happens in one location, that was not being reflected in another location. If a change happens in one computer, it was changed in the server, but immediately that change was not available in the another host. So we have actually now two types of computing going on: centralized computing and distributed computing. Now we'll study some of the uh, forms of computing, okay, and also we'll study in detail distributed computing. What is a distributed system? We will study what is a distributed system, why do we need distributed system, some examples of distributed systems, and what are the features and weaknesses of distributed systems. We can think of distributed systems as breaking down an application into individual computing agents. It does mean one application can be divided into many parts. One job can be distributed over a network. A single job can be done by many people as a cooperative task. What is the motivation to bring up distributed computing? The first one is scalability. A large problem can be solved without using large computers. What do we mean by large computers? With high memory power, with high processors, and so on. With the small or uh, smaller computers, we can solve bigger problems. The second motivation is openness and heterogeneity. We know many companies started developing different hardwares and also different softwares. So in a network, heterogeneity started up. Okay, actually, it was the biggest problem to the porting of one application from one configuration device to another device which has another configuration. So to avoid heterogeneity and to build up openness, open platform systems, the distributed computing concept came up. Fault tolerance is another feature which really motivated the distributed computing field. Redundant processing agents for a system were available. Now let us compare the decentralized computing systems and distributed computing systems. In centralized computer systems, there will be mainframe computer, maybe referred as a server, and terminals will be connected to that. If mainframe computer collapses, all the entire works of the company or the the system will be completely collapsed. Whereas in distributed computing, there is no mainframe computer or a single large computer. Every computer has its own contribution to the whole network. Every computer is connected to the to another computer and through a internet link or to a network link. Thus, if one computer collapses, the other two computers in the network will continue the job and also will take over the job being done by the computer which collapsed. Collapsed, I mean, stopped working or hanged up, all these things. What is distributed system? The definition. A distributed system is a collection of autonomous hosts that are connected to a computer network. Autonomous host. It does mean that every individual computer has its own capability, its own work. Okay. Next is each host executes components and operates a distribution middleware. When two or more computers are connected to distributed systems, there will be a middleware which connects the different hosts. The middleware enables the components to coordinate their activity. Different hosts will be uh, functioning with the management of the middleware. Middleware will be seeing that the components are working synchronously. Users perceive the system as a single integrated computing facility. It's as good as four persons lifting one big stone or one big bundle, but it looks as if one person only has lifted. So, though there are four or five computers are working together, the user will not be able to identify that there were many computers connected together to handle one task. Why we need a distributed system? We have different types of models in our business or in our day-to-day life. We have manufacturing models, we have payables, receivables, money paying, checks and bills, etc. And we have accounting softwares, we have inventory softwares, we have payroll softwares, we have shipping, receiving, and logistic softwares. We have science and engineering softwares, and also we have sales softwares. Different, I mean to say, heterogeneous softwares will be working, applications will be working. We need to connect them together through and manage them as a single system. So if a middleware is developed to connect all these and managed by a single location, each one of them will contribute to a larger work, and that is how the distributed systems will be developed. Okay, so we have already studied distributed systems solve the problems of heterogeneity. They are network, they are physically disparate, and they are from vendors. As it is seen in the previous slide, manufacturing and inventory. Manufacturing application is developed by some client, some company, and inventory or payroll system is developed by another company, but they work together. There is no question of platform dependency. They are these all these work as if they are working on a single platform. So for application requirements and non-functional requirements, we need distributed systems. The biggest advantage of distributed systems is scalability, concurrence, openness, heterogeneity, resource sharing, and fault tolerance. So we will compare again with the advantages of both systems. We will compare centralized and distributed systems. Centralized systems will have non-autonomous components. Each one of them are dependent on a server computer. Centralized systems are often built using homogeneous technology. All the computers connected to the mainframe computer should be of the same type of platform. Multiple users share the resources of a centralized system at all times. Individual system is not existing on its own. It is completely dependent on the mainframe computer. or a server computer. Centralized systems have a single point of control and of failure. Okay, as we have already studied, if the server fails, the entire system will fail. Whereas distributed systems have these features. Distributed system are autonomous computers. Individual computer or individual system is on its own. It can work on its own. It is not dependent on some other system. Distributed system may be built using heterogeneous technology. All the components attached to distributed system need not be of the same platform or same operating system or same type or from same or developed from by the same company. Distributed systems components may be used exclusively. Distributed systems are executed in concurrent processes and they have multiple points of failure. And if one point of failure is there, we can ignore that. The entire system will ignore and will function without any disturbance. Advantages are shareability, expandability, local autonomy, improved performance, improved reliability, potential cost reduction, and the disadvantages are network reliance. Everything depends on the speed of the network. More and more complexities. As the individual components are autonomous, there may be one component with high level configurations and some other computer may be of lower configurations, and this may lead to speed differences and related complexities. Security is another biggest issue which are being dealt by many researchers now. Multiple points of failure may lead to unavailability of the whole service. The history is in the late 70s and early 80s, synchronous distributed processing was started. There was no point of central control in mid 90s over distributed systems, and more fine-grained distributed came up in 90s, 1990s. Some examples of distributed systems are video on demand. The first example is video on demand, VOD we call. Client components are used to display videos. Clients are hosted in the homes of the customers of the service. Server components load and transmit videos. Multiple servers are needed to order to scale. Okay, the videos are not present only at the server components. They just load the videos present all over the world. One computer or one client demands for a video, and the server will search all the components connected to it which can supply that video and will play that. Multiple servers are needed in order to scale. That is the biggest disadvantages actually there. Another example is IT infrastructure of a bank. Okay, a bank may have a authorization service, client service, or customer service, ATM service, trading service, etc. And all these are interconnected together over a network. Okay, so different hardware platforms can be used within the bank's IT architecture. So this is the summary is we studied what is distributed system, we compared centralized systems and distributed systems. We came to know why distributed systems are needed, and we also studied the advantages and disadvantages.